We out here. We out here. Okay. We out here. You. Okay. Okay. Category gaming. I do understand the implications of my actions. Well, in general I don't, but in this case I do. Okay. Okay. Okay, I'm ready. I am ready. I just need some of my feedback to kick on here. Please and thank you. Okay. All right. So where I needed to change my TQ. We've just been working on the ECS system. I forget where I left off yesterday, but I have done a little bit more work on it. What was the last thing I did? Oh, I was optimizing the caching, the copying, the per frame copying. So yeah, I did get that to work a lot better. So I think yesterday it was like 10 milliseconds. Now it's like, I think I got it down to like 4, which is pretty good. I still think it can be better, but that's pretty good. It's pretty good. That is a lot better. It's a lot shorter too now. The actual caching function. Get rid of all these fucking stupid comments. I need to rewrite this one. I don't know what I'm going to do here because now I got rid of the notion of a use script struct in the system, but I do need an interop for that to get information from blueprints. Great cache pool for type. Am I using that? I don't think so. Okay, you can go away. Dude, all these vlogs I need to put in like a separate... I feel like I need to put those in a separate file. Yeah, dude, all these templated ones are so messy. Okay, but anyways, I think I was going to change the TQ because I actually did find out that there is a new TQ that is potentially more performant. I found this comment. This queue is planned for deprecation in favor of TSPCQ or TMPSCQ. SPCQ? SPSCQ. There's so many letters. TSPSCQ. But looking at so one of them's like a what is it, multi-producer, single consumer. The other one's single consumer, single consumer. I think they're just used for the different scenarios where it's like a one-to-one or a many-to-one relationship. And this is a fast multi-producer, single consumer, unbounded concurrent queue. So I think this is actually going to be, we'll see. We're going to flip this queue over and see how much faster it is. Because the queue is what we use for the command buffers. So we'll see if this is going to be like a tightly packed queue now. Allocator type equals F memory. Is there any other option? Are there any usages of this in the engine? There are. There are plenty. Of that, there are plenty. Wow, they use it for a command queue as well. Sound generator. And they use it in mass entity. I wonder if that's why it was built. Interesting, interesting. Yeah, I'm not seeing anything where they're overriding the what was it, the memory part of it. So yeah, it looks like everything is just like the default. I'm not even sure what the other options would be. That's why I'm looking. Ah, yes. Hello, I am back. Welcome back. Good morning. Okay, yeah, so I think I'm just gonna pop that bad boy in and see how much faster we get. I should still have the old performance profiles so we can compare side by side here. 89 actions. Okay, so we got a minute, guys. We got a minute. Should have been building that the whole time. And so what's next after that? Let's say we get that working nice and nice. I guess it would be time to kick these off to the background thread. So let me take a peek at for each async. I may need to rewrite that. I mean, it's the same as for each. And maybe I should... I also have the parallel for each. Which I'm not going to do that. That's going to be the last thing I do. Because that's going to kind of construe my performance a little bit, because it's no longer going to be like a one-to-one comparison. So that's going to be, once I get everything ironed out, then I'll switch to doing parallel fours for some, probably most processors. Most processors will be a parallel four. And then I guess what we need to handle next is data over. Well, I guess the processors probably just straight up aren't working at the moment. So we'll probably, let's get those fixed. And yeah, I think it has to do with the overwriting. They're overwriting each other from the command queue. So if they're all on the game thread, they can all just edit the data. And they don't need a command queue. They can write to whatever data they want to. And honestly, if they're all parallel fours running on the game thread, I mean, that might be performant enough. And I'm wondering how much lower can I get the overhead of caching the data to send to background threads, because it just may not be worth it to run fully async anymore. But that kind of worries me, because I want that ability. Now look at these chickens, crazy looking chickens. Unreal Engine, hello, there we go, thank you. Because now there's like a, if I need to copy any data, there's like a 4 millisecond. And maybe I can be smarter about which data I need to copy, so I only copy the necessary data. But the worst case scenario is the same. Or it's right now is 4 milliseconds on the game thread for 2,000 entities. I'm not sure what other ways around that there would be. I could try to do the parallel 4 copy. Could try that, but it's like I'm gonna need to do some fancy C++ to not cause that to just end up back on the time to just end up back on the game thread. Okay, what do we got? 2,000? Yeah, so let's just click play. Probably not gonna see anything here. How'd you get my picture for your background? Hey, ask Microsoft. Bill Gates must have snapped that pic. That's an automated Windows desktop image. Okay, so this doesn't seem that much faster, I'll be honest with you. That's disappointing. Gonna trace. There are things happening. There are things happening, I promise you. Okay. This is the new one. This is the new one. Yeah, that doesn't, I don't think that was any faster. I don't think that was any faster at all, actually. Fuck is the point? Does it have different methods? Move temp if possible. So I'm just dequeuing into a buffer. Okay, let's not copy that. Data is about, yeah, we have to do that. Okay. I mean, that might speed it up. That small change might speed it up a little bit, but like, yeah, it's not gonna be, I'm not saying, I mean, fucking target entity found real ID. We can just comment that out. So that might be slightly faster. And then, I mean, I guess I'll just double check the old ones. Grab one from yesterday. It might be slower. It might be even slower. 5 milliseconds. What is it? Process pending command buffers. Okay. So we have a max of 7.4, average is about 4.5. Yeah, it's actually slower. I'm actually gonna guess it's about the same. I'm actually guessing that it's going to be about the same, and it's just probably a difference in, you know, whatever state my fucking CPU is at the time. Let's check just a different one. An older one. Let me see here. We'll do this one. Oh, that one wasn't doing anything. It's a bad one to check. There we go. We want the big reds. Yeah, it is. Actually, it was faster. Okay, so I just made it slower. Never underestimate my power to fuck up my own code here. Oh, damn. Okay, let me give this another run, just to make sure. And I guess I'll flip it back. I hate rebuilding that whole thing, though. Yeah, let's just go here. It's really laggy while we're spawning. Yeah, it's not good. It's not good. Yeah, that's okay. That's what I would call worse. Yeah. Well, that's disappointing. Okay, so what's my next move here then? Let me see here. I need ideas. I need ideas. Okay, so I'm wondering. Oh, that wouldn't. That didn't even complete, did it? That didn't even rebuild properly. I mean, that's a very, very small improvement. So likely to see no improvement there. I'm wondering if, in order, because like the reason I'm using a queue here is to be able to write to it from background threads, but I'm wondering if I just give each processor its own like little pool. Let's give it like its own little, not pool, but its own little array. We'll do a tightly packed array or something, you know? So that the array can specify any like async stuff, or then the command buffer can process. And then in entity system base, that's what we do for the process pending command buffers. We iterate over here. Which, yeah, we could do that. Well, we should probably do all of them first. So then that would turn into something like this. Okay, let's try this. Let's try this. We're gonna go T array, F command buffer. I forgot what did I call the type? F entity command buffer. Okay, I was close. I don't think I can forward declare that. Okay, so we're basically just gonna empty that. What is the most efficient way to empty that? Yeah, and it has to be not processing. Yeah. Otherwise, if it's processing, we would hit the we would hit an exception. Yes, we would. Yes, we would. Okay, so we're gonna go const f entity command buffer ref there. Buffer, pass that in. Okay. And then I need to make sure, oh, that needs to be, can I do const here? I don't, can you move temp? I don't feel like you can't move temp on a const. And then I kind of want to like pop the command buffer, you know what I mean? And then I should probably like aggregate that into an array, right? Pending command buffers. And then we'll do something like this. Make sure that's a ref. Yeah, then I think that would be faster. I think this is actually technically faster. Disjoin, what are we working on? Just refactors to my ECS system that I've written. Right now we're working on the command buffer for asynchronous tasks. Rewriting this a little bit to see if we can get it to be faster. Okay, so we have each buffer and then we're gonna add it to the pending command buffers. Can I move temp? Is that what I should do? And then processor command buffers, we what? Dot reset. Memory can stay allocated. My brother, what are you working on? I am working on refactors to my ECS system. Currently trying to make a new command buffer approach where each, because I was trying to write to a queue from the background thread. And that was not very performant because it seems like the TQ is not a tightly packed contiguous array. Now I'm going to try and make one. And let's, why don't we're going to reserve 2 times instantiated processors, the number of instantiated processors. Is this C++? It is. Wow, you got it right. You're like one of the first people to get it right. I was just commenting yesterday about how no one comes in here and actually says the right thing. Like, is this Python? Actually, do they need more than one? Do they ever need more than one? I don't think they ever do. Do they? Add entity data generic, add function, add entity data. Yeah, I want to do a scope trace on this. CPU, or what is it? Trace, CPU, profiler, event, scope, string, F string, scope name. I want this to be like add entity data. And then let's just do that. Or can I just get the entity data type? I mean, there's no way, right? There's no way. There's no way I can just do that. Yeah, maybe I can't. Maybe there is no string to add here. We'll just let's keep it simple for now. Just see how long the add entity data takes. How can I hire you to help me make my own operating system? Why on earth would you want to fucking do that? There is nothing fruitful for you in that venture. You're not even learning anything at that point. The Genuine Geek. Thank you for the follow and welcome in. Good morning. Good morning. Okay. Yeah, do they even need... I don't even think they need a fucking array. Like, I think this can just be a single command buffer. I think that can just be a single command buffer. And then can I check its... Yeah, we'll check if its commands are empty or not. Get commands is empty or something, right? Okay. If commands dot is not empty, we can do it. We can do the thing. So I don't know if is move temp the right move here. Hey, with the Prime sub, Genuine Geek, thank you so much. I followed after I heard you say, "Why on earth would you want to do that?" Hey, I'm glad you share my opinion there. I'm glad I'm not the only one. I appreciate your support, my dude. Thank you. It means a lot. Thank you. The Prime sub. I'm new here. Nice to meet you. Nice to meet you as well. I would have liked the coding stream if I understood anything. Well, stick around, you might. Happy to answer any questions. I don't... Move temp feels weird here. Move temp feels weird. And we would want to, like, reset that, right? Yeah, we'll see how much this little part is here. All my CPP experiences in robotics and embedded systems, so this is a bit of a different beast for me. What exactly is an ECS? Some sort of command queue system. It's quite a bit more. Command queue system is just one part of it. So an ECS system. Yeah, let's take a step back. Let me walk you down memory lane. An ECS system stands for Entity Component System. And it's just a data-oriented, data-driven way to process like thousands and thousands and thousands of entities of like NPCs or just, it's typically a video game architecture. And one of its main principles is using some of your processor's principles of cache locality. And what that means is that your processors are very fast at doing things, What they're not fast at doing is going to grab memory from RAM. That is the slowest thing that they do, pretty much. You can think of it like, you know, if you have a pointer versus if you have a ref, right? If you have a pointer, your processor needs to go figure out what that pointer is pointing to. It needs to take a trip to the grocery store, right? Whereas if you have a struct that's just a ref, you already have it in your pantry. You don't need to go to the grocery store for that, right? And so when you're for looping over things, if you're using a pointer in your for loop, the processor needs to go grab that memory from RAM and bring it all the way back and put it in the processor memory, which is like the pantry that's the analogy I'll go with here. Now, it doesn't just go to the grocery store for one thing, right? That would be a waste. It goes to the grocery store and it picks up everything physically next to the memory that you need. So it's like you have a pointer, it'll go to your RAM. It doesn't just grab that pointer's worth of memory. It grabs like, I think at least 64 bytes worth of memory that's next to it, physically next to it in the RAM. And it's called a cache line. So it pulls the whole cache line into the L1, L2 cache or whatever in the CPU. Now, why is that? You know, how can you take advantage of that? You can take advantage of that by having very tightly packed arrays, and what that means is your arrays are they are a contiguous block of memory. There's no gaps in them in memory, and so when you iterate over them, when your CPU needs to grab the memory, it will grab everything for the next iterations, and that literally, like the performance benefits from that are like tenfold. It is crazy how much faster doing that is, if you can get that down. And so you're just taking advantage of the processor's like kind of prefetching in a way. It's just it grabs a whole chunk of memory, not just the only memory that you're asking for. And then if you understand that what memory you'll need next, you can store that next to each other. And then when it grabs it, it'll iterate really fast. So it attempts to recursively move those objects rather than randomly accessing. Recursively wouldn't be the right term there, but it grabs it just grabs a whole chunk of memory at that location, more than it actually needs for like a pointer or for whatever memory or something like that. And pointers are like locations in random memory. So using pointers is kind of the antithesis of an ECS system. In the ECS system, it stands for Entity Component System. So the entity is just an ID that represents, data. It represents it's like the key for a bunch of data, and your data is the component. That's the C in ECS, and then that's you're supposed to have very tight, small structs, so that when your processor goes to grab the memory, it can grab more than one. Right? If you have really large ones, it'll only ever be able to grab one at a time, and you'll lose the performance benefits. And the S is system. That's the things that iterate. Those are the iterators, or I call them processors in my system. So yeah, that's kind of like the TLDR. There's a lot more to it when it comes to like running asynchronously and stuff like that. Like if I want to kick everything off to the background thread, there are threading concerns, read-write locking issues, that kind of stuff. So that's what we're working on now. I'm working on like I have a command buffer, and that's where like a processor. Right now, I'm just gonna, because in my old system I was using U objects, which were pointers, so I completely got rid of like the notion of cache locality, and that was just so like I could iterate fast and figure out what I needed from an ECS system. Now I'm refactoring it to just use structs. Now I'm refactoring it to take advantage of these things. I've already done a little bit of a test here, and so here was before in my old system. This is my move to processor, this line here, and so we had a max of 135 milliseconds for one run of this processor for 2,000 entities. Average was 30 milliseconds, median was 34. Now with all I did was switch to structs, right? All I did was switch to structs, and I changed the architecture a little bit, nothing fancy. Now move to only takes 23 max milliseconds, average is 8.5, median 8.7. So it's literally over a 3 times performance improvement, and I'm not even really fully taking advantage of a lot. So there was much more performance on the table that I can get. That was just one quick and dirty test run there. So we're already fucking cooking. And I've broken it like 3 or 4 times over now, trying to trying to squeeze more performance over it. So that's what we're doing today. Buddy, why you think the 5th time is the charm? Is that maybe 6 or 7 times, and I'll answer. You realize you're asking an Unreal Engine developer whether Godot or Unity is better for a 3D open world? maybe you should ask Google. Because I don't know. Because I don't work in those engines. See, beginning to make sense now. Yeah, I'm happy to clarify further if need be. But yeah, we're working on, like I said, the command buffer part. And so, like, if you're running all of these processors asynchronously, they're going to step on each other's toes, right? Because these processors are going to need, they're going to have overlaps in the data that they need from the entities. So, like, the velocity processor takes in transform data. The move to processor also needs to take in the transform data as well. And so, if you edit the transform data while reading the transform data from another thread, that's going to cause an exception. We can't have that, right? So what I've done is I'm actually going to copy all of the data. And that's like one of the steps, as I'm making a cache of all the data so that I can send it to the background thread and that it can be completely isolated from any edits that happen, right? And so that's why we need to cache it, and that's why we need like a command buffer as well, so the things on the background threads, on these asynchronous task processing threads, they can still edit the data without having the actual reference to the data. They have a copy of it, so they're going to post to a command buffer. That command buffer has like what action needs to happen. Then we process that at the beginning of every frame, if the processor is done running. So yeah, we're going to use not a queue anymore, which is what I was using before, because a queue is not a tightly packed contiguous array. So now we are going to make one of those. We are going to make one of those now. No, I guess it does need to be an array. They do need to be an array. I'm dumb. I don't know why I thought they wouldn't. I don't know why I thought they wouldn't need it. Yeah, they do need an array. They do need an array. Now, this is only going to work for... This is only going to work for a sequential, not a parallel 4 command buffer. We'll start with this and then we'll update it. We'll start with this and then we'll update it. But we do need this to be a for loop. We do need to go back to the for loop. These processors run per entity, right? Okay. So let's move temp for each command, but well, we just want to. Should I append the whole command buffers? Can I move temp at that point? Probably not. Pending command buffers. What are you mad at? Oh, I would need to append. And then can we move temp here? Does that actually save us anything? The move semantics are something that that I would appreciate a better understanding of. Yes, because for most of my knowledge, WorldStream is not that great in Godot, and a Unity developer knows more about it than me. I am not a Unity developer. I am an Unreal Engine developer. So Google knows more about it than both of us, so you should start there. And my phone keeps trying to answer me. Stop that. How does that work for async write? Or do you just not write to that memory using the background there? Well, that's what the command buffer is for, that I was just saying. Like, the first step is copying all of the data, and then you send that data to the background threads, so that the background threads are completely isolated from anything else that happens, right? Because they're just operating on copied data. The command buffer takes in some commands as to the writes, like what kind of write needs to happen, what should I replace the data with, that kind of thing, right? And so when the next iteration happens on the game thread, we check the command buffer. Are there any commands to process? Process them, you know. And so I'm going to see if this works a little faster. I'm going to guess that it probably doesn't. And this should actually be activeentities.num times instantiated processors.num. Oh god, this is going to be... Yeah, this might not be that performant, really. Allegria. Thank you for the follow. Welcome. And then we're just going to move temp there, reset the command buffers. Is that all I need to do then? And then we can iterate over pending command buffers. And give me a trace CPU profile event scope for this guy. And then I think let's rebuild. Is that, well, I actually need to fucking add to it, don't I? From these processors. Yeah, that's probably what I should do. Yeah, crazy. Post command buffer, let's just comment that out. That way the compiler will tell me where I need to update this. So now instead, we need to command buffers dot add buffer. Then I should make this command buffers. I should pack this up as well. So when we get here, reset to, I don't have active entities, do I? So let's make a function for getting the number of active entities. Int, I think it could probably be int 32. Get num entities. Okay, and then at that point, we wouldn't need to reset it. Yeah, we wouldn't need to reset it in the subsystem. Yeah, so we'll leave that for the processor itself to handle. So we need to do that, and then we go in there and add, yeah. So yeah, we just need to make sure we're like reserving the proper data. That's like step one. And then you can see how much I'm doing in these processors. It's too damn much. And this, I think I should actually in place. I think an in place would actually be better here. Yeah, I should be doing it in place here. So that it gets created in the array. Just carry the 3 and press enter. Oh, God, you're so right. Okay, so that's it. That's an easy one. Okay, let's do this. I'm gonna copy both of those. That there. Okay. Okay, we need to do this for every single processor now. Every single one. Entity iterate target. Wait, does this one not update anything? It only updates the ASC, okay. Which is a pointer. which is why this one sucks. Yeah. And I don't need to, I don't need to do anything for that one. Don't need to do anything for that one. State tree processor, okay. Command buffers dot reset entity subsystem get num entities. Okay. Representation processor. You don't do anything either. You don't do any commands either. So ignore you. Moving tag. You're not even a processor anymore. Moving tag processor. You need to not be right there. Most of these are already fixed. Most of these are already fixed. Okay, okay. We're working through it. Okay. And I don't know... Okay, yeah, this one does have one. Okay. Chunk processor. You don't do any updates either. Okay, you do. Okay, I think that's it. And we compile now. Opa. And a good opa to you as well. Yeah, I'm wondering, this has a high chance of not being, local variable buffer used. Oh, yeah. Okay, so that was bad. I wrote that wrong. Okay, hang on. I think we can probably just do a replace all here. Replace all, yes. Okay. Yeah, I think this has a high chance of not being any more performant than what I was already doing. But there is a chance. Bro, you still working on it? Oh yeah, I'll be working on it for quite a while. Don't you worry. It'll be interesting to see how... I wonder if I should probably wrap that. Well, I guess we'll see because the playback command buffer is there. I respect that, bro. Thank you. Yeah, this one this one might be a little, this might be where a lot of the performance goes. Because we have to read the pool pointer. And that's what's going to cause our slowdowns, is having to read this pointer. I wonder if I should deref it here, you know? Yeah, I guarantee like this could be, so actually everything now needs to run on like a the template meta programming required to write this is getting difficult, because I think the most efficient way to actually do this, to add entity data or to, you know, to process this command, any kind of edit to the system where it's adding an entity, deleting an entity, editing an entity, the best way to do that is to do it on a per data pool process. Right now I'm just doing it ad hoc, meaning like whatever's in the queue, just do it, right? Regardless of what data it's editing. So I should probably have a templated command buffer, which, oh boy. But I guess I could just put that command buffer on the pool itself, and I wouldn't have too many issues with it. Okay, let's run. It's going to be very slow, and we're not actually going to see anything because I've broken the processors. But we do get the performance because they are running. They just don't work correctly. I don't think it's any more performant than what I did. Maybe a little bit, actually. Maybe a little bit. Yeah, I think we got like maybe 5 FPS out of that. Hell yeah. Oh yeah, that's like twice as good. Oh yeah. What is all this? What is all this empty time here? What is all this? What is all this? We have 1.3 milliseconds of nothing. Oh, the plate. Look at how fast this is, guys. We've literally hit the maximum resolution that Insights can show us, which is 100 nanoseconds. Some of them even say 0. Oh, see, that one said 0. 0. It took 0 time. That's crazy. But like, you see how like this is the result of like having a tightly packed array. Like, do you see? I mean, at least this is my understanding of it. I might be wrong here, but like, I think this little gap here is pointer chasing, right? Where I was going to the grocery store to grab some memory. And so like all of these were already in the CPU's local memory. So we just got all those like super fast. And like, we get these big chunks of processing that can happen. There's a big gap right there. Okay, so what is all that? What is all that? There's a ton of just empty space there at the end of the process pending command buffers. What on earth would that have been? Just buy a better CPU. Oh yeah, I'll tell that to my players as well. Just buy, because you all have phones. Just get a better CPU. I'm learning cinematics for game development. Do you have any suggestions about that? None at all. I've not done any cinematic anything, so can't help you there. Hey Steve, welcome in. 5 FPS, let's go. Yeah, it's all about the little steps. Little steps. Yeah, what the fuck is the rest of that performance? So it looks like this, when we're packing up the array to process here up front, I can see that there's a little bit of time for that. What is all this? Playback command buffer. I mean, what else is there to actually... It doesn't do anything else in this scope. Let's look at another frame. Is it always like that? Yeah, it is. Yeah, it is. It's so much better, though, doing it that way. Holy shit. And you know, actually, if I do it on a per pool basis, I can actually run all of them in parallel, because I know there will be no collisions between pools. So I think I can get that down to like under a millisecond if I do that. Minimum requirements, big. Yes. It is going to require a lot of RAM. The RAM requirements are going to be quite high, I think. I think it's going to be minimum 16 gigs RAM kind of game. And I'm hoping that just kind of becomes the norm by the time this comes out. I feel like 16 gigs is a minimum spec now, right? Like even in laptops. I want to know what all that empty space is from. That seems really weird. I wonder if it's just not tracking correctly because the numbers are so small. And so it's not displaying properly. Like, I wonder if these are actually going to take up that whole space. Or should have. So I think that move temp there is good. I think that is a good move temp. And then in each processor, I think maybe those got a little bit longer. Yeah, because we have a little bit up front where it's not doing anything. That would be the resetting. Dude, the chunk processor is running fucking amazing now. Holy shit. 300 microseconds now? The chunk oh god, if you guys would have seen the first iteration of the chunk processor. Oh my goodness. I think it was like 20 milliseconds at least. The chunk processor is what takes all my entities and puts them into different chunks into the world. And then that way, when I do like an AoE ability, I don't need to iterate over every single entity to check if they're in the AoE. I can only just check the local chunk, right? Or the surrounding chunks. And that's important because none of my entities have collision. So I have to like kind of like just do math to check if they're in things, you know? Lucky in embedded systems, you basically assume there is no heap since many embedded devices have none. Yeah, well, at least that like kind of forces you to write things performantly, right? I guess that kind of needs to be a copy for this, which I'm not using, but yeah, I would really like for there to not be that big empty gap at the end there. It's so crazy that all of that happens so fast. So the add entity data is actually quite fast. Wait. Oh no. Okay. Uh-oh. I didn't see any add entity datas. We're not doing anything. That's why it's so fast. Yeah. This programmers hate this one simple trick. Yeah, just don't do anything. And turns out the processor runs great. Yeah, I'm not hitting that. Okay, fuck. Oh yeah, we're using this stupid add entity generic. Which we should get rid of. Because it's that's gonna be slow. The data type is null actually now as well. How is that? Data type is indeed null. How was I populating that? I guess I never was because we're initializing an instance struct. So I need to do cmd data get struct type actually here to actually do things. Yeah, so that was just wrong. That was just wrong. That's why we can't see anything. So I've actually just solved that issue. So that's great. Okay, yeah, now we've gotten there. Oh boy, I can't wait to see how much shittier this runs. Yeah, there they are. Look at them. Yeah, we've lost about 10 FPS. We've lost about 10 FPS now because of that. Well, at least we're actually doing things. It's still not working correctly, but we are doing things. Okay, we got our little trace here. Let's see. Okay, process command buffers back up to 7.7 milliseconds. Now it's still happening very fast. It do seem to be tightly packed. Okay, and the add entity data is actually not so bad. Add entity data is quite quick, which is surprising. But there is some overhead just from the playback command buffer. And then there's still that gap at the end, which I'm not sure why. What? Okay. Yeah, so there's overhead. I'm gonna guess it's from this. Yeah, let's throw one in here. Trace, CPU profiler. Oh, I missed it. CPU event scope, yeah. What is an ECS system? The TLDR is it is a data-oriented architecture that relies on principles of cache locality, which is like a processor architectural optimization. So you take advantage of that using tightly packed contiguous arrays, and you can run thousands and thousands and thousands of entities in the world. The ECS stands for Entity Component System, which are kind of three different pieces of the architecture. Entity is your ID, component is your data, and system is the processor that operates on data. And then you'd have many of each. Okay, finish spawning, please. Yeah, we're back down to like shitty performance. All our performance gains have gone now that we're actually doing things, which makes sense, I suppose. Yeah, there's a lot of overhead for that. Yeah. What happens after that? There's nothing that happens. Like, why are you... Yeah, this, we need to make this not generic. We need to make this not generic. So let's make I think we first of all need to make a templated add entity data. It is templated. This, however, is not. Can entity command be templated itself? Maybe we should do that. Template. No, we want type name. Type name. Entity data type. And so data then becomes entity data type. Get rid of those. We don't want that anymore. Goodbye instance structs. Goodbye. And so we want to still just forward. This is now entity data type. Forward that to just the data. Can I forward there? Can I forward there? Remove. That we just get that by nature of the templated struct, which I suppose now we need to like create it templated. How do I do that? Or no, it's a command. So when we add entity data, we need to, this now is going to be type name entity data type data entity command add forward t. I think that's okay. I need to template this part rather than the add. Okay. I hate that that doing like the template programming just loses all of your code coloring. And then I need to do the same here. Just forward that entity data type that we will rename here. Boom. There we go. Okay. F entity command buffer. I guess this now needs to be... I need a type erased version of the struct as well, I think. Yeah, okay. So we need a T-base entity command. Oh boy. T base. T, we'll just say entity command base. And then this will extend from T entity command base. And then this should have, what would I need on that? Commands? I think just commands is all I would need on that. An array of commands. Now, is it going to be T entity command base? It's not virtual. Yes, it will need to be virtual. Yeah, non-parallel. Wait, what are you saying? As a non-virtual public destructor. Wait, how did I set him up in here? We need to do that. I see. I see. Is abstract. And so this... Okay, so what would I need to use? I'm not convinced that that's what I need. Hang on. Are you doing all your code in C++ rather than blueprints? Most of it is done in C++, yes, but I do use blueprints for things. Constructor's not going to hurt anything. But for an ECS system, it kind of has to be in C++. That's the whole point, I think. It's a major point of it. And so, yeah, we're going to add entity data, but we will have the buffer when we're doing that. This will be templated. It should be, at least. At that point. And then in our processor, we are going to get the templated version of it. Now, here's probably where I'm diverging to doing a per pool, per entity data type command queue, I think. I have to wrap my head around how I guess I have to store them similarly to how I'm storing the entity data itself. And so here's that data pool. Oh, it did F as the base. Okay, hang on. And then T as the templated version. Let me swap those around then. So rename this to T entity command. And this will be F entity command. I guess that makes sense. T for template. Yeah. And then I guess everything has to store it as go to just one of my processors here. So if I store this as well, I have the command buffer. T entity command. I think this should return F entity command base. The Boojum. Welcome. Thank you for the follow, my dude. Thank you. Then these are now the type erased structs. And then these commands will be type erased. So F entity command. No. Yes. T array of F entity command base. Yes. Yes. Command. I think it's safe to say that that we can do like a virtual function for F my entity get entity. And then this can, yeah. Does it have to have virtual on it? I don't know. But then that way we can just command.get entity here. Now we have that type erased version. Type, I think, is also one that we'll need. Virtual e command type get type. Yeah, and let's actually spell virtual properly. That's important. That is important. Turn that there. So we will do a get type there. Get entity. I mean, I already have target entity there, so we're just going to use that. And then the actual data. Now, this is where it's going to diverge quite a bit here. The data is an entity data type. Yeah, I wonder if I need a... What would that return, right? What would that return? How do I get the type of this type erased thing? Let me look at how I was doing this already. Get entity data pool of type. It's just everything needs to be templated. Everything needs to be templated. Okay, so in that case, do I need to template the playback command buffer itself? So we only and then we only process one data type at a time. And so really it would turn into pending command buffers, an array of T entity. Oh god, what would it be? I might need to go to Gemini for this to give me an idea. But I want to think about it myself to kind of, so I can get better at this. So this is the type erased version, F entity command buffer. Well, no, this is just the container, right? This is just the container. It's not until we like get commands, right? So this is the F, there we go. This is the template version here. So get commands. I basically need to change this to extracting on a per entity data type basis. And I think there's probably some C++ pack parameter syntax that I can do. Get commands. What is the move temp doing anything there for me? I think I should probably do that. Unless there's like a way, how would I, if I have a type erased version, is there any way I can code, like I can, what's the syntax for getting the template from here? Is there even a syntax for that? First of all, let's get rid of the temp to real ID map. I'm not gonna worry about that at the moment. Ah, shit. Okay, maybe we are. Okay, just put it back. Get type, there we go. Command.data. Yeah, I might just paste some of this into Gemini and be like, hey, give me how to do this on a per template basis. And so I no longer want to do the generic functions because that's where a lot of the time is going. Having to like follow these pointers. And if I just make like a virtual, well, even if I make a templated function, I have no template to pass into it. Okay, Gemini, you're gonna fucking help me out here. All right. Let me pull up one of my old ones here. Okay. All right, so give it this. Well, first of all, let's do this. We are going to just give it this whole file, I guess. Give it the whole file. Let's go entity command buffer.h. Give it that whole file. And then we'll go entity, playback. We'll give it this right here. Oops. We need these two. Give it these two functions. We're vibe coding now, boys. We're basically Quinn69, basically. This is in entity subsystem.cpp. Okay. Okay, so what am I asking it? I'm saying, can you help me change this? I'll say change the command buffer processing to handle it on a per entity data type basis. The previous implementation relied on generic U script struct lookups, which was a bit slow due to following the pointers. I believe that handling the command buffers one entity data type at a time will allow better performance due to not needing to follow both generic type lookup pointers and also ad hoc entity data pool pointers. I'm also going to ask it if this is correct. Is this the right idea? Okay. Gemini, I just need the syntax, basically. This is where my C++ knowledge kind of fails me. So we're going to let that cook for a second. Thinking. Yes, of course, yes. Your intuition is absolutely correct. That's a fantastic optimization, dude. Gemini just glazing me up right now. But if it's cache coherency, you can process all commands at once. It means you find the entity data pool once and its internal arrays stay hot in the CPU cache. Yeah, that's exactly what I was thinking. It just said it very nicely. Much nicer than I did. Eileen Egg. Thank you for the follow. Welcome. It's a massive performance win over just jumping between pools for every command. Yeah, that's my thoughts exactly. God, Gemini said it so much better than I did, though. How's the website refactor going? That CSS is looking good. Oh yeah, we're cooking up some really good CSS here. Yeah, you know, get rid of that. Eliminates virtual dispatch overhead. Yeah. Oh, I don't need virtual. Okay, it's telling me I don't even need. I just added those because I thought I needed them. It's like, hey, you don't need those. Okay, we'll see if that's true. T data. Okay, it's changing the names of everything now. Can we avoid doing that? Show me the playback logic. Assuming processors store their own F entity command buffer, which is a good pattern. Let's grab them all. Yes, that is what I was doing. We should probably reserve here. It's not reserving any memory in that array. We should probably do that. Playback command buffer. Yeah, okay, so here's the juice. Destroy entities next. Process component by pool. Okay, so it put all the logic in something else. Get command pools. It stores a pointer to the pool on itself, okay. I don't know if that's what I'll want to do. Get or create command pool. You know, I wonder, we should probably just put this on. I think I want to, we should just put them on the data pool itself rather than creating new types for everything. I might rerun that query, that prompt. Where the hell? Here we go. Yeah, so I think we should probably have another one here. Yeah, I think that's better, and it'll be cleaner. It'll be cleaner. So hang on. Let me. I'm just gonna read this real quick. We have playback, which I hate that term. What does that mean? What does it mean? The base, all it has is just a playback function. So the subsystem has the add entity data one. Is that already, that's already there, right? Yeah, it's already there. We already have that. Yeah, we just call that directly now. Okay, that makes sense. That makes sense. That makes sense. Okay, so let me rerun this because Gemini, you didn't cook up perfectly, but you gave me some good ideas, which is what it's there for, right? It's like it's not perfect, but dude, what is happening right now? Collapse code snippet. Oh, that's new. I don't know if it's working. I can't tell. I wanted to go to the top, but we're gonna just delete, I guess. Yeah, just delete, and then let's go to top. We'll edit my prompt here. We'll edit that, and then. Is this the right idea? Let's just say, I think the command, I think each entity data pool should store a command buffer array. I'll just say, I also think should store a command buffer array instead of using instead of creating a bunch of different classes. Classes/structs. Okay. Rerun it. How long have you been working on your game? Almost 3 years now. Going on 3 years here soon. And so let me just show the game here real quick, since probably some people in here who haven't seen it. We're waiting on that prompt. So here's it's going to be an RPG Colony Sim Roguelite with procedural terrain and AI generated quests. I got to make sure the spawning is turned off because yeah, that won't work right now. So here's some of the procedural terrain. And here's me. PCG still spawning. I think we're still spawning grass. There we go. Yeah, it's just a little sidestep into the world here. That's awesome. Thank you, man. This is the procedural terrain is kind of my pride and joy. Here's the world map itself. So each one of these is like a different zone that'll have like a different biome and stuff like that. Multiplayer? Yeah, I hope so. I haven't really fully done multiplayer stuff at the moment. Like, pretty much only the player is replicated and nothing else. Like, the entities aren't replicated, the building system isn't replicated. I don't think any of the ISMs would be replicated either. Close that. But yeah, these are the zones. There'll be like different biomes and stuff like that. I'm hoping to have like dynamic biomes, so they're not like the forest biome isn't always the forest biome. You know, there could be some different things in there. You solo dev? Yes, I am. Nice mountain. And we got the underground caves as well, which are super sweet, I think. Oh, that's a nice chunk just taken out of the side of this mountain. I have dynamic tree chopping as well, so like wherever the axe connects with the tree, it actually edits it at runtime using dynamic meshes. So it was a static mesh. I got 7 wood from that, and I can keep chopping. And I got 10 wood, so I got 3 more wood. There you go. And you can just punt stumps. Yeah. I just started and it's pretty daunting. Yes, it is. Yes, it is. It's an absolute slog. You've got a ton done. Well, it's been a long time, and I've been working on this like religiously for 3 years, so. I do have destructible terrain proof of concept. I'll see if I can. It kind of sucks. Yeah, the animation I have that I made myself really sucks, so. It does like technically work here. If I can actually get it to hit something. There we go. There we go. So that is destructible terrain. There you go. It deformed it at runtime. Now it looks like shit. And it's not actually useful. But there you go. There you go. So yeah, RPG Colony Sim Roguelite, so I'm thinking something like Vanilla WoW plus RimWorld plus like a Hades or something like that, you know? Oh, this is my Meadows biome. The big trees. Anyways, yeah, small little side journey there. Back to the test level. Okay, Gemini, what do you think? Jesus Christ. Okay, that was a lot more code. I don't know that I like that. How are the roguelite elements going to work? Yeah, so as you level up every few levels, you'll get like 3 different abilities to choose from. So think like if you pick like a vanilla WoW class, and as you level up through vanilla WoW, instead of just getting abilities every 2 levels, you know, like new ranks of abilities and stuff, instead you'll be picking abilities like from random, like, you know, pictures, like, you know, kind of like Survivors, you know, Vampire Survivors or something, where it gives you 3 choices and you pick one, and then you start to create your build, and hopefully I'll have enough abilities for each class that each run will be different in the builds. And then you have static talents, and you'll need to pick talents that are like complementary to the abilities that you've gotten. And then for the colony sim side of things, like when you die, you'll start over at level 1, but then your colony is still going to be there, and you'll likely just respawn in your colony or somewhere nearby. And so your colony might get attacked while you're dead or something like that. And you know, or it might not, or maybe you've set up your defenses really well and your colony's still there, so they have like a bunch of resources now for you to use. Or maybe you had a blacksmith, really good blacksmith colonist who can make you like really good gear and stuff like that. That's how those two systems will kind of interact. It doesn't handle commands that aren't specific. I don't care about those commands though. Those happen from outside of processors, I think. I think those happen from outside of processors. It says it wants an entire subsystem. Centralize the... Oh, in the subsystem. Never mind. Okay, that looks a lot simpler than what we got last time, though. The F entity command buffer that processors use will no longer store commands itself. Instead, it'll become a lightweight proxy or facade that forwards command requests directly to subsystems' new typed command buffers. Subsystem queue data command. Yeah, I mean, that's not that different from what I have already. Update the subsystem to manage the new members, the new buffers, rather. Oh yeah, we need to do the data type ID, which I guess apparently works, which is a crazy little piece of C++. That those data type IDs actually work. Dedicated simple buffers for global commands. Yeah, okay, that's fine. Yeah. Oh, we're doing a mutex, huh? Okay. Okay. This is seeming like a simpler approach to it. Rewrite the command buffer processing logic. Process pending command buffers. Oh, and then we need to add the processors to the, yeah, okay. The ID resolution for component commands within process pending command buffers is complex. The simplest way is to ensure your add and remove functions. Check the temp to real ID map before accessing pools. Keeps the processing loop clean. Better to add virtual functions. Resolve temp IDs. I'm not convinced I need the temp IDs. Gemini keeps thinking that I need them. I'm not convinced. For simplicity, we'll assume add entity data and remove entity data calls will handle ID resolution. I'm fine with that. Register command processor. Yeah, so I need to do that as well. Okay. Yeah, so the whole like notion of this like template meta programming, like one of the main concepts that I've figured out that is important. Well, I haven't figured it out, but like Gemini has told me about that I've realized is important. Is like it creates these global lists of like you have to register the data types that you're using, and then it creates these global maps that you can use to like look them up by this like ID that gets it uses these really fancy tricks to like make sure that this ID is unique. I don't know, it's super weird. I never would have come up with it in a million years on my own, but it is like a super important concept. But it wants me to do it this way. Wait, hang on. Let's before we get there, let's go back to the top here. We need to change the entity command buffers here. Do an add command. Command buffer base. F command buffer base. And this is going where now? Create a new header. Okay, so we're just gonna slap this in the entity subsystem then. That seems fine. Okay. And then these guys, this one might be weird now. Well, entity command buffer. Yeah, let's actually put this in the command buffer. That I think probably makes more sense for now. Does it? Actually, I don't know. Put it in the back in the subsystem. I changed my mind. In the command buffer. The command buffer needs to get created with the subsystem and then assign it, I suppose. Okay, and then everything's basically the same. Yeah, I guess I don't need the equality operator anymore. Yeah, forward declare that. Subsystem equals end subsystem. We will get rid of that. So do we still have the create entity and so I guess do we just like forward these ones as well to the subsystem? Add entity data. We're just gonna add it now directly to the subsystem, which is incomplete. Okay, so yeah, that's not going to be able to be forward declared. Okay, so include that. Now we need to make these guys. You create entity. Okay, so I'll need to use those as well. God, this subsystem is getting so fucking gnarly, to be honest with you. Fucking gnarly. The command buffer mutex. I think with the way I'm going to call this, it won't need the command buffer mutex. Can go all the way at the bottom. Okay, and then my, like the create entity ones, what was it, create and remove? Are not templated. But I guess we probably just put Q create entity command. But I need to return the hello? Are these not public? No, they're not. They are not. They are not. You create entity command. But I guess this is where I create the new entity. F my entity. This is such a good song. And then destroy entity command buffer add. We just return void there. Okay, so we got those wired up, I think. Q entity, rewrite the command buffer processing logic. Okay, so here's, yeah, let's do this part now. So I'm going to copy all this. This will need to change a little bit though, because it doesn't actually work that way. So what I have to do is one of these, like, I guess this is like a trick to get it to return a static global list here. Okay, so we're gonna put that here, and then that needs to be get command processors. Yeah. Get or create entity data pool, which is inaccessible. Okay. Let's make it accessible. Like, this is such a strange syntax to me. Like, look at that. This is a new thing I figured out. Like, sometimes it doesn't know if you're doing less than or equal to a number. Like, the compiler doesn't. And so it's like, hey, you need to tell me that you're using a templated function here. Which is so weird. Okay, so now when we register a data type, it'll register these command processor things. Okay, so that seems to resolve. Process pending command buffers. Let me look through here. Yeah, I like that it's assuming that I'm going to handle the ID resolution, because I'm not, and I don't want to. And so this is an entity system utils get command processors. F any placeholder type. That doesn't seem correct. What is that? What the hell is that? Okay, I see why it wanted to do a mutex here. Yeah, I get it now. So I might rewrite that part. And so the playback command buffer, I guess, is no longer a thing. This isn't a temp ID. So I should create entity in that queue thing. Where did I put that? Queue. Yeah, we should do create new entity. Right? I mean, why wouldn't I just create new entity here? No, I don't create new entity. We just create we create the entity, but we don't set it as active until we get here. Yeah, that's the new entity. So we go active entities dot add new entity. There we go. Basarmiente. Thank you. Thank you for the follow. Welcome, welcome. Is that all I need to do, though? What else happened in create entity? Just compacting a little bit there, too. I think that's all I need to do. But when we create, it's like get or create entity data pool, right? Well, I guess it would be when we add. Yeah, I mean this. I'm not going to use this. I'm going to handle this completely differently. But that's fine for now. That's fine for now. Okay, what is this F any placeholder type? Risky cast just to access members. Better to add virtual function. What are you're not even doing anything with this. Resolve temporary IDs within this buffer. Yeah, I'm just gonna delete that. Value pair. Command buffers by type. We get the command buffer. And then our function here. Does what? It just calls add entity data for us. I am working on refactors to my ECS system. So I'm trying to do typed command buffers for asynchronous entity data edits, basically. So this actually, now that I'm looking at it, why do I need to do this whole thing here? Why can't I just... We have T. I mean, I guess this creates it. It'll create entity data pool. That's fine, but do I need to look that up? I think I can do better than what the Gemini or ChatGPT can give me. The point is to actually learn. And I know that's wild to think about. The point is to learn and not be completely reliant on AI. The point is also to understand what my own system is doing and how it works. I will remove entity. Why is that happening here? That's not right. Yeah, this is confusing that we need this. I think we should probably just do this, where T is... Well, yeah, well, this is how you access the template. And how are we adding the key here? Command buffers by type. Or each command buffer by type. We're never actually adding into there, are we? To create entity data pool. Typed buffer. Remove commands, add commands. Yeah, I don't think it ever actually... Oh, find or add. I see. Q add data command from the entity subsystem. Did I forget to copy this over? No. Okay, so that's where it adds it. Okay. Q add entity data command. And so we would iterate through each of those. Those already have the type ID on them. So yeah, why do we need to do this then? I don't think we need to do this level of indirection at all. Because we can just... It's a map of... But I already have the buffer. So I'm just passing the buffer. Why can't I just use virtual functions here? I guess I get it. I guess I get what it's doing, but why can't I just use virtual functions here? Rather than that. Because now I'm like following so many pointers. I don't think it's actually going to be that much more performance here. I guess we can always just try. How much do I need to do to get this to resolve? Let's see. Let's see if this even works. Well, I guess I need to change all of the, yeah. There's no generated file. Okay. Yeah, so there's this syntax doesn't work anymore because we just fucking changed everything. So yeah, we're gonna template here. Now, can it infer the template, perhaps? Can I infer here then? No, I don't think so. And then, yeah, this will need to have only one type of data in it, so I can't add both of these to the same buffer. F entity command buffer, is that the generic one? Or that's just that's the container for it, right. And that just acts as a proxy to the subsystem. I mean, I don't even need that at this point then. But I guess that's why the mutexes are in the entity subsystem, which I don't want, because we can just iterate over these guys. Like, do I want to do that? I guess the mutex isn't that bad, and it would be nice to iterate over. I mean, that probably saves us. The mutexes actually might save us a little bit of processing time. So yeah, then we wouldn't want that. And it was just saying do like a create one, like on the fly, yeah. Yeah. And I mean, at this point, I might as well just call the subsystem. Like, why do I need this at all anymore? You know, I'm just going to subsystem q add data command. Entity. Yeah. I mean, that I don't know why I would need that entire class now, though. That's just not necessary anymore. We do need to go through and fix all these. Avatar data, attach data. Let's see, what else didn't we do? Attach chunk doesn't do anything. We already did that one. LOD, that's good. That's good. That's not one. There we go. Entity, move temp, yeah, state tree data, there we go. Does this one... I guess we do nothing there. Velocity processor, we've already got you there. Okay, so do we compile now? Is this compilable? Only 91 actions. No, it is not. No, it is not. Yeah, I don't want this anywhere now. But the type is still like all over the place. What are you complaining about? Can I just comment everything out because I don't need it? Subsystem identifier not found. Because I didn't import it or something? Yo, let's just comment everything out for a hot second here. Syntax error, F entity command. Why are you so angry? Why are you so angry about this? What on earth is the fucking issue here? Okay, so I get why these are. Can comment out the playback buffer. We're not even using it. Playback command buffer. Okay, still lots of fucking issues. Why is it mad at my entity processor? What the fuck's the deal there? Yeah, that's gonna be. We're doing so many comments, so much comment version control here. You, my entity processor, undeclared. What? Like, why is that undeclared now? We are importing it. There's some sort of weird, like, dependency issue happening right now. Okay, hang on, just pause for a second. Okay, yeah, that's an issue. Yeah, that's an issue. That's an issue. Unspecialized class template can't be used as a template argument for parameter in element type. What? I don't understand what changed such that the entity processor has an issue. The declaration of you, my entity yeah, but like why? The subclass of. What fucking type is it talking about? Do I get rid of the entity command buffer import there? Was that the issue? I think that was the issue. Okay. Weird. Weird that that manifested that way. Okay, we're going though. It's working. Okay. Okay. Finally, that completed. Okay, I guess we just get to see if this works and how well. Okay. Things are happening. Performance is okay. Performance was okay. You must have a really good GPU. None of what you're seeing is happening on the GPU. So now the command buffers is kind of back down to 2 milliseconds, which is really good. So we're back to where we were. Hopefully, wait. Okay, let's make sure it's actually doing things. We might be back down to where we're not actually doing things. Am I seeing the add entity data? I am. Okay, so we are doing things then, I think. Okay, so yeah, that was a big performance boost right there. By like, what was it, like 4x? That's a 4x performance boost. I think that's happening properly. So let me look in here. Let me take a peek. So we're getting a lot of what I think would be cache misses here. We're getting some hits. We're getting some hits. I'm wondering if I should like dereference the pointer. Command buffers by type, and then is this like compact, you know? You go back up here. And so we would give it the buffer. Apply additions and updates. What if I did this? What if, I'm curious what would happen if I did this. And I do have to rebuild fucking everything. Tell me about a .inl file. Significance of an INL file. Oh, just a structure. Okay, so literally no compiler benefit. Okay, that kind of sucks. Okay, but this does seem to be working. So I think I want to delete the entire command buffer now, because we have these individual command buffer queues, and I want to make sure that these are nice and packed as well. I mean, I guess that's just create and destroy, which we don't really care about. But it's like this add commands that needs to be added to. So this queue add data command might be the next place of improvement. Are we almost done here? I make a unique, so we're storing them by pointer. Should I store them by pointer? Do I work somewhere? I do, not in game dev though. Let me see here. Should we be storing by pointer? Doesn't that reduce the performance of iterating over the commands? Just see what Gemini says about that. Honor. Okay, let's run it back. Oh, nothing is happening now. Literally nothing is happening now. Why did that make nothing happen? That's an interesting result. Oh, because it's not a ref. That makes sense. Okay, so we have to rebuild all of that. Okay, well, it's telling me that it's a well-managed trade-off. I have 3 options. One layer of indirection, the pointer. Yes, that's what I'm worried about. The cost is not where... Okay, where do you think the cost is, AI? Because I'm thinking the cost is in the queuing things up. I don't think it understands what I'm trying to say. Like this buffer, this command buffer is by type, I suppose. Is that what it's saying? We can replace the T-map with the T-array and use the ID as a direct index. Yeah, now we're talking, baby. Now we're talking. Okay, let me look this up. I mean, it's honestly this is what I'm worried about, I think. So let me see how it handles that. All right, run it. See if that's any faster. Okay, finish spawning. Might actually be slower. That might actually be slower. Why would that be slower? I guess I'm still dereferencing the pointer. I thought only doing it once would be different though. Yeah, what part got slower? I don't actually understand. Learn chatting with AI to never ask yes or no questions. There's just too much glaze bias. It's like 50% of the time glazing you. I don't know. It just told me no just now. So, are you a game developer? Just hobby time stuff. And default thinking is ECS built around array of structs mindset, so pointer storage is almost de facto the answer. I don't know what you mean by that. Why would dereferencing the pointer once and then adding to all these things be slightly worse than that? Yeah, I feel like storing things by pointer is not the... I mean, I think it's fine for some things, like a per... Okay, yeah. Anyways, storing by pointer. I mean, I think it's fine. I guess the part that for each command buffers by type, and then we're processing. I mean, yeah, I guess it's not that bad right here. I guess it's not that bad right here. I mean, a lot of these are very contiguous. But I don't know like how accurate this is, because I know we're like at the kind of the bottom of the resolution. But yeah, I mean, storing by the ID because it's an integer would be good. For all of these, I think. So that's something that I can maybe keep in mind, but I suppose... this is basically as good as we can get. Now the destroy and create, I think I can compact those a little better. But I think this is good. I am just using a mutex now for the command buffer instead of kind of a queue. So I'm wondering, I'm gonna put a trace CPU scope here. I do want to see how long these take. And for these add commands, should I compact here as well? Should I compact there? Go ahead and rebuild, and we'll just think about that while it's rebuilding. This is gonna fucking take a while. So it means the queue is gonna take a bit more time. But the intention for this is to happen on the background thread, so... Okay, we can't compact. We can't compact arrays? Wait. Why can't we do that? Why can't I compact an array? Maybe setting some arbitrary threshold to force compact so smaller buffers don't bother. I don't know if I need that level of optimization. That's kind of overkill. Git command processors. Right. So you can wait, so why can I not? Is it because it's templated? I thought you could compact arrays. Was I fucking wrong? Maybe it was only sets. Maybe you can only compact maps and sets. Okay. What are you doing? In all caps. Game dev. Refactoring ECS system. The ECS system I wrote. So now, like, there's still the biggest part of the game thread is still the data copying, which got better, but it's like 4 milliseconds with 2,000 entities. So that's not very good. And Jack RJ, thank you for the follow. Welcome. So I'm not sure what other improvements I can make. I did have a... And actually, I one I can make is that the command buffers can be parallel forward now, because they only do individual command buffers. So each command buffer can go on a different thread, potentially. That might have to be like a custom parallel for, maybe? There might be a templated one I can use. Now, the generate frame data cache.
Hello.
Hello.
It's John Cena.
It's John Cena. Oh, Jack. Welcome in.
Why are you running?
I had no idea.
Why are you running?
Mango Tear. Put it in reverse, Tear.
Thank you for the raid. Welcome in, Raiders.
oh, Lord. Ladies and gentlemen, we got him.
Hello.
What the dog doing?
Hello. Tell me about yourself. What were you guys doing some development? What kind of development were you doing? Game dev? Other dev? I'm unfamiliar, so please, ELI5, Jack RJ. I'm doing well. We're working on my ECS system at the moment. I've had it working for a while, but I'm like going through and refactoring and trying to like just squeeze every ounce of performance possible. But I can show the actual, we can show the actual world here. Let's not open the nav mesh at the moment. So I am working on an RPG Colony Sim Roguelite with procedural destructible terrain and AI generated quests. So here is one small section of the procedural world being generated before our very eyes, complete with underground caves and tunnels with things in them. They're not super interesting yet, but eventually they will have like ore and monsters and stuff spawned in here. I usually have stuff spawned into the world, like a bunch of NPCs and stuff, but I'm working on the ECS system, so it's going to be kind of empty at the moment. But yeah, tell me, you are a game dev or something like that. Yeah, me too. So yeah, what were you guys working on? How was your stream? So yeah, I'm going for like a vanilla WoW plus RimWorld plus Hades. I have dynamic tree chopping. The trees get edited at runtime wherever the axe connects with them. There will eventually be like a tree chopping skill, right? Oh, come on. One more. Oh, I missed. Okay. Come on. Okay. I just suck at my animation sucks. There we go. Okay, so that chopped. I got 7 wood from that. And I can continue chopping. I can continue. Eventually the tree chopping stats will affect that, like, plus your axe stats, and then ignore the shitty materials that I haven't fixed. Yeah, and I got more wood, so now I have 10 wood. And then, you know, you can take that. There's a building system. We can build things. There will be a construction skill as well. And you will need to actually spend time building. This is to facilitate the, like, colony sim side of things. So you should be getting your colonists to do this for you, basically. And then they'll have their own stats for like construction stuff. That's like kind of like how RimWorld works if anyone is unfamiliar. It's insane. You're amazing. Thank you, man. I'm working on a Souls-like survival multiplayer. Hell yeah, that sounds fun. I'll have to check you out. What game engine? What game engine are you using? Someone grinded woodcutting in RuneScape. No, more so Valheim, actually. I was not a huge RuneScape player back in the day. Maple Story was actually my jam. But I'm more so getting the tree chopping from Valheim. I definitely want to implement the tree dominoes. You know, where you hit one tree, it hits another tree, it knocks that tree over, and then you like level a whole forest with like one swing. That was always super fun. So eventually those trees will do damage to you and stuff. But yeah, here's the world map. Each one of my zones has like a different name. It's all like procedural as well. So like Cindervale Basin over here, Frostwatch Tundra, the Land of the Chimeras, the Sunken City, the Dryad Grove of Renewal, the Goblin Market of Green Gristle, Ember Reach Bastion, Crystal Bloom Sanctuary. And this is all like a randomly generated map, and each one of these are different zones. They're surrounded by mountains, each of them. So you can see like there's this like kind of border mountain here. And maybe I can get a different seed to show it off a little bit better. What are we on? We're on 599. Okay, seed 600. Seed 600. So there we go. Here's a good example of two different zones. Although the terrain is a little boring here. A little boring. Oh, this is a good example. This is actually ocean over here. That's why it's flat and nothing is spawning. That's supposed to be ocean. But you can see here, this is one of those white dots on the map. It's a zone entrance chunk. And so that creates a break in the mountains. And that's how you get from like zone to zone, right? And I suppose that was down here. I suppose that one was over there. Or something. But I spawned on this little tiny island, which is not a very good spawn. But you can see that just the difference between the two zones. So it's actually kind of a bad seed to show off anything. Community dev, gotcha. Eventually I'll be spawning like points of interest and stuff. And so you usually have to find those zone entrance chunks to get from zone to zone, but you can also do... I love that little section of noise. I love this. You can also sometimes find like a cave, a randomly generated cave, or like right here you could just walk over it because the noise blends into it. Or you could dig through. You could dig through, or you could build up and back down. Okay, seed 601. Okay. Okay, so kind of a flatter, rolling hills type zone. There's another zone entrance chunk right there. I like this. There's this nice vantage point here. Do you use LinkedIn? You're not getting my LinkedIn. Nice try, hacker. Nice try, hacker. So yeah, that's the procedural terrain. I'm working on the ECS system today, though. It's a nice cave system there. But anyways, thank you for the raid, Jack. I appreciate that. I'll have to check you out later. And if you need to go, please do so. Why? Mushrooms here. There'll be like a foraging skill as well. Oh dear. I didn't mean to do that. I did not mean to do that. Uh-oh. Uh-oh. Okay, I think this just ends up generating forever. It's just gonna generate underground caves forever. Goodbye, cruel world. Okay, back to the test level. Really need to go now, but your project blows my mind. I hope for the best for you, and we'll be here more times than learn with you. Hell yeah, I appreciate the raid. Thank you. Yes, please go and take care of what you need to. GitHub. I don't have anything public on GitHub. Ripro, like, you're not getting my personal information. Like, it's not gonna happen. It's not happening. So yeah, it's a little broken right now. A little broken at the moment. But here we are. Here we are. We're doing some pretty like intense C++ changes now. Yeah, so I used to do, so like the largest, let's take a look at a trace here. All right, yeah, I'm not sure why you think you would get my personal information like that. It's not gonna happen. The frame data cache is actually now more expensive than I thought it was gonna be. But all my processors are running on the game thread now. That's why the performance is kind of shitty. But the processors themselves have had a massive speed up. But now what I'm trying to focus on is this section right here. The one section is processing the command buffers, which is like all the writes that are going to happen to the data. We've gotten that down pretty well. 2 milliseconds is good, and then this can also happen in parallel pretty nicely. It can also happen in parallel pretty nicely. And I was doing a parallel for caching the data. I need to cache and copy all the data so that when I run things on the background thread, they're like completely isolated, you know, from any edits that need to happen. I'm wondering, what if there's like a clever way? Is there like a clever, how about your MySpace? That's funny. Or how about my Xanga? Does anyone remember Xanga? Is anyone old enough to remember that? I'm wondering if there's a clever way to where I replace the data rather than edit it, so that I don't ever have to copy it unless I'm editing it. Does that make sense? So like right now the flow is do any edits that have been put in the buffer since last frame, cache all the entity data, or just, you know, make copies of it, and then we process entities, which means that we're taking those copies and giving it to the entity processors. This way they can run. I'm not running them on the background thread currently, but this is so that they can run on the background thread. But I'm wondering if like we just we don't do a copy, get rid of that, give the actual ones that exist in memory to the processors, and then when we do the edits, is this, if you just replace the memory that's there, I mean, that would cause an issue, right? That would cause an issue. Question mark? I think it would, right? Because this is like inline data of the array. I wonder if just using mutexes would actually be better. Like, let me think about this. I mean, I think that would cause an issue. I'll ask Gemini to confirm, either confirm or deny. Okay, let's delete our last prompt here. Delete, let me see here. would it still cause threading issues if I were to not copy the entity data to each entity data for each async processor and instead treated the original data as I'll say old as the old data and just replaced data in the data pool arrays. And instead just replace the data in the data pool arrays. With any copied, updated data, if there is some. I don't know. This is kind of a shitty question. I don't know if it's going to understand what I'm asking. Have you given Claude Code a try? Yeah, I don't really like the command line interface. Like if I were to, I would just use Copilot, right, which has Claude. And there's a Claude 4 here, like. You should remove the move. Why? If I recall correctly, that in-place move temp does nothing. I think that makes sense actually. If I did add, oh ass, add, then that would do something. No, because in place takes parameters. It takes parameters, right? This probably should be an add. It probably should be an add. You've asked one of the most advanced and insightful questions. Oh my god, spare me. But absolutely, the caught threading issues, double. But the pattern you're describing is the foundation of a very powerful technique called double buffering. Oh boy. It's the same entity. I mean, I guess I'm already doing this though. Gemini sounds like Jimmy from South Park. You've stumbled upon one of the most advanced techniques. The flip. One frame lag? I am accepting that. I hate the flattery baked into the AI responses. I know, right? Like, just give me the info. I don't need you to glaze me. How do you stay so focused? I mean, streaming kind of helps with that, honestly. It's like, what else am I going to do? What engine? I am using Unreal Engine. I don't want to do triple buffering. That sounds like overkill. Let me read this again. 2 sets of data pools. I actually did think about that earlier. I was like, what if I just maintained 2 sets? But then I was like, how would I resolve that? But I guess this is telling me how I would resolve the inconsistencies between the two. Yeah, so you have read data and you have write data, and then you just swap them back and forth or something. Is that what it's saying? A read pointer and a write pointer. Why are we using pointers though? Oh, it has a pointer indicating which state is canonical. I see. But do you need to copy things? Crucially, they're all given read-only access to read state, state A. This is completely safe because state A is immutable for the duration of the frame. There are no writes and there are no data races. Cool. When a processor calculates a new component state, it writes that new state into the corresponding write pool, write state, which is state B, right? Yes. Since each processor is typically responsible for writing to different component types, are often conflict-free. If two processors do write to the same component type, you have a clear rule about which ones wins, or run them serially. Frame ends the flip. All parallel processor finishes work. State B now contains the complete updated world state for the next frame. The subsystem flips the pointers. Read state now points to state B, and a write state points to state A. Okay, and then you process the command buffers. But when you process it, you have to apply them to what now? Yeah, the command buffers apply to both states. I don't know that's going to work. You should definitely try Claude Code. I have. I have access to Claude right here. Like I don't need a command line interface when I have Claude in this menu. I guess I think what it's not accounting for here is that I'm going to have long-running async processes. This is assuming that every processor completes within a frame. I think is the issue. I'm just gonna say, would this handle long-running async processors that do not necessarily complete in a single frame? So I don't think it would. Copy on start, command on finish pattern. Yeah, I mean, this is what I'm doing now, though. So I'm just trying to figure out if there's a better architecture. And it remains the correct approach, yeah. I guess the copying is not happening fast enough. And I'm doing this the most efficient way. Because if I did this in a per processor thing, I'd be doing more work than necessary overall. So let me think about this. Would this be easier to parallel 4 through now? Let me look at the let me look at the trace again. Let me get some more information here actually. Let me get some more information about where okay, trace, CPU profiler, event scope. Let's call this copy loop or something. Yeah, I don't really use AI very much. Like, I'm using it a lot now just to help me with like the super low level C++ stuff. But like usually in development I don't use it, so okay, we have to rebuild. So that's why I just kind of use it as an ad hoc thing. I don't want to pay for Claude Code either. I wouldn't use it enough. And so I think I could maybe parallel for this. I want to get some more information about what's slow here though. So we're doing a lookup we're doing a per. Then we clone is doing it for. We're gonna use the default copy assignment. Okay, so I guess actually before I go through all this copy loop, and then let's just like do clone. Like how much of that is from the looping pointer stuff, and how much of it is just from the copy itself. And then when I'm doing the for each, I need to make sure that I'm not accidentally doing any copies there. Yeah, we get the smallest pool or whatever. The data pointer tuple. Does this need to be? Should that be a pointer? We're doing the data array and getting, yeah, I mean, I guess we're packing up all the data. Base, cast it to the typed pool. It's a pointer. We do a find. I feel like this is slightly, I mean, no, I think this is probably pretty necessary. Yeah, no, this is pretty necessary. Okay, are we done building yet? This thing takes like several minutes to build anytime I make a change to the entity system. It's just used in so many places throughout the app. Okay, so we're gonna get some more information from that, but then I think I would want to... I could do each one of these on a separate thread. As long as I gave it the cache pool... What are we doing here? What is cache pools? To a pointer of entity data pool. Okay. Okay, it's gonna be laggy while they spawn. We know this. We know this. Okay. Look at that. Okay, so, oh my god, half of that isn't even... Half of that is just emptying the cached pools, and... I mean, most of it's got to be that, right? We empty. That should probably just reset instead. The cached pools is a... Okay, I mean, I guess we can really quickly see if that made any difference. Okay, done spawning. Race for a bit. I'm not seeing any better FPS, really. Not really. .5 milliseconds. Max 7, average 4. Max 7, yeah, didn't really make a difference. Yeah, so there's a lot there. The frame data cache. All you have in here is cache pools. I feel like that's not necessary anymore. Just get rid of that. Oh, look who it is. Look who it is. Cache pools. Hello, Mart. Okay, so the cached pools. I need to like get, so it's a pointer to a pool. It's a map of ID to pool pointer. Get pool factories. Okay, so how would I isolate this from... I guess I would just dereference the pointers and then the copy can happen on the parallel threads. Let me look at this a little closer. Yeah, like each one of these could happen on a parallel thread. Now, the upfront part of it, do we need to reset here? I don't think so, actually, because we're just gonna reassign. We're just gonna reassign it now. Does that mean I'm just kicking this off to the back? Which that would be fine, actually, if I kick this off to like a potential parallel thread. So I'm gonna spec that out while this is building. Parallel for each. I know there's a bunch of different ones of these. I need a very specific one that allows me to specify the number, I guess, or like the context. I need to give it context, right? Or is the parallel for with context? I don't need pre-work. Parallel for with task context. Out contexts. I need like an input context. Existing task context. Right, I create the... I assume context and num needs to be the same. One task per context at most. Okay, yeah, let's do that. Parallel for with existing task context. Now I need a T array view of, I guess it would be whatever the hell this is. Entity data pools, find type ID. Wait, what am I doing here? Source pool. Okay, yeah, that, I need it for the data type ID, I guess. T array view, all required types dot array. I think that's fine. Does it need to be array, or can it just be all data types? Can I do something like this? Input argument deduction failed. So parallel for with existing task contexts. Then I need the data type IDs. Or the thing is, I need to hang on. I need to do this. Find with, okay, so here's what we need to do actually. I need to create T array of T unique pointer, an array of pointers here. Hashed pool pointers, and then we just add to that. Add. That's also dot reserve cache pool. Yeah, that add. I guess because we're gonna set it equal here, or I need the. Can this be a ref to the entry of this map? Actually. Just give me, is there not an entries? Oh, I'm using the wrong thing here. Yeah, that would be cached pools dot entries or something. All required data types. I mean, I might as well iterate over the cache pools. Make sure that that is a ref. What type is this? Is that not correct? Add. Would I need to like move temp? No. Okay, well let me, now that this is built, let me test this real quick. I don't think this is much better. Yeah, see now I'm just splitting it across frames, which is actually, I'm just kind of trading off there, yeah, so I want to split this across. Can this instead be like a pointer ref? What am I using new cache pool for here? What is it? What is this doing? Okay, hang on. What is that? What is that doing? Is that necessary? Okay, why is that slower? Why is that slightly slower? I mean, that factory was really doing nothing though, so that doesn't need to be there. I guess the thing that I'm questioning here is, like, I want to do this parallel on separate threads. Each of these copies can happen on a separate thread. Right, and then we do the cache pools at the end. Okay, yeah. We're just going to get the source pool pointer and make a clone of it and put it in. Okay. The clone, and then we'll probably do some move semantics or something. Okay, so this auto clone, I'll just say, or like data copy, and then I'll want an array of those T unique pointer, returning F entity data pool base. Just that should be maybe a ref or not. Okay, maybe not. This is what should be in the parallel for. I think that means we can just do a... It's a fucking set. It takes like an N32 index. Get the dependencies, which is a T set. I mean, just make an array, I suppose. Just do dot array here. Pass that in by ref, I think. Copy is fine actually. But I need to put this. So what do I fucking put this copy in? Because I can't edit the map in parallel. Is this where I need the out context? Parallel for, and I guess it was with task context, and then what debug name? Sure, give it a name. Give it a name. Wait, why don't you like that? What is tchar? Is it not text? What the fuck am I supposed to put there? I thought that was text. This is using text. What the heck? Okay, I think maybe it's complaining about something else. Text. Out contexts. Which this should be a T array of this. Num. Context constructor. Oh god. Oh, never mind. Do I want this? Is there one without a constructor? Oh, there is, and without a debug thing. Okay, nice. And so this should take, it's not going to be out context, right? What function body? Function type. F task context, okay. Wait, hang on. What was F? Oh, do I have to, that needs to be like a specific type, right? F task content. Okay, yeah. So we need to make that the context equals, there we go. I think that works. And then at the end, after it's done, for each required data type, well, this should be a for I. No, give me the for I. Writer, hello, please. Where is my for I? I have to write it manually, like a goddamn plebeian. Yeah, there we go. Have AI write it. Okay, is this faster? Let's pray. Everyone pray that this doesn't crash and also works faster. Uh-oh. Crashed. Okay, I didn't do that right. I didn't do that right. Okay. That returns a T-unique pointer. Now, the move temps and stuff, maybe I'm not... Should I move temp here? Is that even possible? That is technically possible, I suppose. I think I'm just gonna give this to Gemini and be like, hey, fix this shit. Hey, yo, fix this. Okay, give it the code. I'll just say, I'm trying to cache the per entity data pool data in parallel, where each pool is copied on a separate thread. Can you fix this for me? Channel's definitely underrated. It's fun to watch and learn from you. Oh, I think that. Thank you. I appreciate that. I'm glad you're learning something. Oh my god, it's spitting out so much code. Okay, so it still wants me to clear. Why? I'm just finding. I'm not editing. Is it pre-allocated? Maybe that's where the issue is coming in. Okay, so you still want to clear. I don't know that that's necessary because we can just overwrite it. Yeah, get the required data. Okay, it's making a literal struct. I mean, we can just do like a tuple. I don't need to create like a whole ass struct for that. Source pool pointer get. I mean, sure. Parallel thread results. Set num. Okay, you want to do a tuple. I mean, yeah, we can do that. That's a little cleaner. I agree that that's a little cleaner. And then you're just editing. Wait, so how is that able to work in parallel? Okay, I mean, I guess because it's already pre-allocated memory. Is that why it works? So no context. Oops. We'll go no context then. I thought the context would handle that for me, but I guess not. Parallel 4, and then we're just going to pass tasks to run in the body. Okay. Okay, see, I thought it would be more. I thought there was something more to it than this, right? And then pass by ref there. I don't care if we're accessing a pointer there. That's fine. Okay, see that task source pool pointer clone. Okay, so here's where I think it's probably going to. We're cloning into make tuple. Does make tuple? Oh yeah, I do need to make tuple. That's why it's failing. I'm dumb. Okay, do I need to move temp here on that though? I think I may need to move temp there. We'll see. I mean, I'm gonna guess that this is gonna be the same exact performance as before. And then move temp, get 0, get 1. I mean, can I just use key value or does get? Okay, that's effectively the same thing. I didn't use everything that it gave me, but it's effectively the same. I think. Yes, I do. Yes, I do indeed, good sir. Can you run live coding on the right thing? Oh, we're like break pointed. So we need to rebuild it quickly. I don't. It's complaining about shared reason. I don't think that matters. And we'll see if this write actually works. I'm questioning that. And then make tuple is taking in the R value, which makes me feel like I should move temp here. Because I think this is double copying. We'll see. I mean, if it's on a parallel thread, maybe it doesn't fucking matter. Maybe it doesn't fucking matter. Performance is the same. So I think we're just trading. We're just trading. Where the performance is. Wait, that's shorter. Hang on. Why wasn't my frame rate higher though? Yeah, that is shorter. That's about half the time. So wait, where's the performance going then? And then we still have another millisecond of like this right here. Okay, let's see what happens if I move temp here. It doesn't like that. So it's already an R value. It's returning a pointer, right? Ugh. So confusing. But it's like this is already. And if I did a dot reset. You wanted me to just completely empty it, didn't you? But I want to maintain some of that, And like, honestly, the cached pools, maybe I should pre-add. Because then I could just go... Is this better? I don't actually know. That might be better. I'm not running that one yet, but we'll try that next. Okay, waiting for them all to spawn. Okay, they are all spawned. Okay. Okay. Looks fine. That actually it was slightly longer. Slightly longer. So yeah, I think that does make a difference. I think that does make a difference. So let's do like some pre... And then required data types. Yeah, we do need to be able to access that by index. Type ID. And then we're just going to go in here. Add type ID. So we make sure those are pre-populated. And then we're going to reassign at the end. We'll see if that actually... see if that's faster. See if that's faster. Wait, what? What? Cache pools, what are you? Pair not equal to null pointer. Oh, the result is a null pointer. Interesting. So wait, what were the required data types? Can't fucking tell. I can't see a thing. The IDs are... is that right? Oh, I guess they're just initialized, right? So yeah, they wouldn't be. So I guess I need to do a check here if... if that... Why did that work before, though? Interesting. Okay. Hey. Yes, my slaves, yes. Performance is maybe very, very slightly better. I don't 2.4, 2.2, 2.7. Kind of samey. Yeah, I mean, maybe slightly better, just on the max end of things. Interesting that the pre-work is half of it. Like, why is that the case? mean, it's got to be this part right here, right? I mean, what? There's no way that like getting the required entity data is an issue at all. It's weird that this map just takes so much to like unallocate itself or something. Like, how would I get it to like not give a shit about its memory until I override it? Okay, run. Up. Yeah, that's basic. It's basically all. That's weird that that takes a full millisecond. That takes a full ass fucking millisecond. Why? Why does emptying the map take that long? All right, Gemini, why does take half of the total time of generate frame data cache? And is there any way to get around that? What does add do? Should I in place here? Would that be better? Yeah, can I empty it on a background thread as well? Yeah, it's calling destruct, yeah, for everything. Change the cache structure to be persistent. I've already done that, actually. Oh, so like the pointer itself, we don't set. We just update the data or something underlying. Okay, I think I understand what it's gonna do here. Source pool, destination pool. Okay, I think that does actually make sense. So then we can just like cached pools, source pool, dest pool, boot, dest boot pointer. Why was that so funny? I'm a child. The poot. Type ID. Yeah. So the destination pool pointer, we can just like, what does this have? What do you have on you? Get dot, all you have is clone. So I guess we would need to update it to have like a function to accept. Add the copy from function, sure. Yeah, that'll work. I should already have the reset, or no? Do I need the reset? That's on, yeah, okay. Copy from. And then give me that. Good to have for completeness. Okay, sure. Sure. We're never gonna reset it, though. Never. Develop Android apps, and recently been thinking about diving into game development. Where should I start? I mean, there's no single place to start. I don't have any like tutorials or courses or anything for you. I never followed any myself. I just started by coming up with a project and just trying to work on it. I imagine you start very similarly to how you started Android development. Pick an engine, come up with a project, start figuring out how to get it done, you know. I assume at this point, after learning Android and DRF, you know how best you learn. So you should apply that to game dev. Destination pool copy from. Dest pool is a ref. Cached pools. Find. It's a T unique pointer F entity database. Wait, why is my copy from not here? Oh, I have to get and then copy from. And then get that, okay. So yeah, no more need for parallel results at all. Yeah, that's a lot cleaner. That's a lot cleaner. Less questions, more doing. Grab a book, tutorial, engine, whatever. It doesn't really matter where you start. Yeah, I have the same mindset. But now we don't need to do that at all. Okay, this is a lot better. I like this. I like this. Now I just guess I need to make sure that I'm pre-creating them. That I'm pre-creating them if they don't exist. And I guess this is where it's like creating the new pointer, but I don't know. Can it just do that automatically? I think it's just, I think we can just do that automatically. I don't think we actually need to do all of that, because all that does is make unique, which I'm pretty sure the finder ad is just going to do that. Okay, let's try it. Then when do I actually... Okay, so I'm not actually creating the pool pointers. I mean, was I before? I think these are going to be empty, no? Yeah, these are going to be empty. But I think I do need to... I need to do something. And so I just need to make a new... Actually, we'll see. We'll see. We'll see, actually. It might just do it automatically. And if not, it'll crash. Okay. Yep, okay. Yeah. Yeah, no, no, it does. It doesn't create it, does it? Okay. Auto ref pool just equals that if there is no pool. No, that's not what I want. Do I really need to do the templated version here? I actually think I do. And he's just doing desk pool factory. Yeah, okay. Entity system utils get pool factories dot find or type ID. And then this is a function that I just call, right? Okay, yeah, I guess I should do if auto factory equals that pool equals factory factor. I barely know her. Okay. Factory. Okay, rebuild. Oh, okay. I really want to get this finished before I have to go soon. Okay. Run. Okay, waiting. There we go. That's what I'm fucking talking about. Okay, so where now? Why is the overall performance? Why is the overall performance not that much better, right? Like, why am I now maybe feels like I'm paying more? Potentially more. Process entities is 22. Let's go look back through some. Give me one from like, what was the one before this one? I'm gonna look at the generate frame data cache was a full millisecond longer, so the entire subsystem was. I mean, I guess we are getting, yeah, it is less. So let's just do entity subsystem base overall. Compare. Subsystem base. Max 42, average is like 26. Max 40, average is slightly less than 26. Okay. Yeah, the max went down a lot. That's good. Okay, should we drill into like maybe process entities? Can I select all? Yes, I can. Oh, that's a lot easier. So the overall process entities was max 36, average, or we'll go median 22.3. Median 22. I mean, it's so slightly better. It's weird that I feel like I should be seeing a larger... The max is cut down a lot. Average is 20.8 versus average being 21.8. So I guess the average is down a little bit too. I was expecting a bit of a larger across the board increase, but it is... The thing that we've got now is a very scalable caching mechanism. This will not increase very much per additional pools, data pools. Wonder if it'd make a bigger impact in an optimized build. Probably, for sure. I mean, it will, but I wonder by how much. Yeah. I get you. This is the old one. Hang on. Is this the old one? Hello, the copy. God damn, that's a long ass copy loop. At least that's gonna scale pretty well. Should we run a 10K and see how it scales? Let's run a 10K real quick and see how it scales. We're going to be spawning for quite a while. And the thing is, like, it's gonna get a lot better when I start breaking my data chunks up, because like there's a lot of cache missing happening because my structs, my entity components, entity data, whatever you want to call it, is they have many properties on them. Interesting thing happening there. Don't know why that happened. It's still spawning, but at least I can see some things. And then let's just stop. Stop there too. Yeah, there's a lot of shit happening on my game thread. Generate frame data cache now 10 milliseconds. God damn. Yeah, it still doesn't scale. It still doesn't scale very well. The command buffer can be parallelized as well. God damn, I was hoping that that would scale a lot better. Yeah, I think this gets a lot better when I start breaking my data up, because a copy on each piece of data is a lot now. And there's just a lot of collisions and conflicts. Maybe I should start trying to do that. Ugh. I was really hoping to avoid that because of, like, that's going to be a big refactor to my game logic, you know? Well, not logic, but like my game code. Because now there's going to be a lot of different data types and stuff. I think the architecture I have now is like fine. I should kick off these processors to the background thread. Bro, these ticks, like, holy shit. 80 milliseconds. But there's like 100 milliseconds, like a third of the frame time is things that will happen on the background thread. I wonder if I wonder if I could just move the entire entity system to its own thread rather than block the game thread, you know, like have a dedicated thread just for the entity system so that I can do the caching and command processing and without blocking the game thread or anything. I would need to create I would need to do like an F runnable or something like that, like a heavier handed async process. QAdd data command is actually quite fast. Okay, more tomorrow. I have to get off for now. Let's find someone to raid. Let us find someone who is on. Oh, Unreal Engine streaming creating in Fortnite. Let's go Prismatica. We haven't rated Prismatica in a little bit. Send you guys over there. Thanks everyone. Oh, I gotta set up the YouTube's one. Okay, YouTube, you're gonna go over to see Prismatica as well. Save. Well, thank you all for hanging out. Appreciate it. Glad to have you all here. Prismatica, save. Okay. So yeah, great stream, man. Thank you so much. Thank you. Fun to watch you optimizing. Yeah, I'm glad that was fun for someone to watch. Yeah. Makes me appreciate Dynasty Wars back in the PS2 days so much more. Yeah, it's interesting. There's a lot of old games that handle a lot of entities, and they probably use the same architecture. It's been around for a while. Well, thank you for the follow, and yeah, have a good rest of your day, everyone. Hopefully, I will see you all again tomorrow.